Projective Geometry, Volume 1, by Oswald Veblen and John Wesley Young.
Chapter 4, Harmonic Constructions and the Fundamental Theorem of Projective Geometry. Section 34, Exercises. Exercises. 1. If A, B, C, D, E are the vertices of a complete space 5-point, there is one and only one net of rationality containing them all. A point P belongs to this net if and only if P is one of a sequence of points A, B, C, D, I1, I2, ... finite in number, such that I1 is a point of intersection of three faces of the original 5-point, and every other point I sub I is the intersection of three distinct planes through triples of points of the set A, B, C, D, E, I sub 1, ... I sub I minus 1. 2. Show that a planar net is determined if three noncollinear points and a line not passing through any of these points are given. 3. Under what condition is a planar net determined by a linear net and 2 points not in this net? Show that two distinct planar nets in the same plane can have at most a linear net and one other point in common. 4. Show that a set of points and lines which is projective with a planar net is a planar net. 5. A line joining a point P of a planar net to any point not in the net but on a line of the net not containing P has no other point than P in common with the net. 6. 2 points and lines in the same plane do not, in general, belong to the same planar net. 7. Discuss the determination of spatial nets by points and planes, similarly to exercises 2, 3, and 6. 8. Any class of points projective with a spatial net is itself a spatial net. 9. If a perspective collineation, homology, or elation in a plane with center A and axis L meets a net of rationality in the plane invariant, the net contains A and L. 10. Prove the corresponding proposition for a net of rationality in space invariant under a perspective transformation. 11. Show that two linear nets on skew lines always belong to some spatial net. In fact, that the number of spatial nets containing two given linear nets on skew lines is the same as the number of linear nets through two given points. 12. Three mutually skew lines and three distinct points on one of them determine one and only one spatial net in which they lie. 13. Give further examples of the determination of spatial nets by lines.
Projective Geometry, Volume 1. This book was written by Oswald Veblen and John Wesley Young. It was published by Blaisdell Publishing Company, London, 1910, and is now in the public domain. It is read by Jim Renholt, with programming and illustration by Jim Renholt, 2019. Thank you for listening.